So I was just looking through a few of your experiments for homework, which was really, really good. And you definitely got the idea. So just want to talk to you about one thing, and just as a note, okay? So, um, when I asked you to measure the mass of the solid, some of you measured a pen, some of you measured a pencil case, some were copies or whatever, but you all seem to get the idea that you just take the mass balance. So you take your mass balance and you place the object on the mass balance, and then whatever it says here, that's your reading. I think for most people, because what you were measuring was reasonably light, you were getting like something like 35 grams. So I suppose what I do want you to acknowledge in your work is how you would convert that into SI units, because remember grams is not SI. So you would need to divide it by 1,000 and it would be 0.035 kilograms. Okay, so if you could add that little calculation into your notes, that would be brilliant. And the next one I asked you to do was measure liquid. So I got two versions, and that's what I hoped I'd get. So one version is where you tare it. So you take your beaker, put it onto the scales. Sorry, oh my god, I just did that. Put it onto the mass balance. It'll obviously give you a mass, so numbers will come up along here. But then you hit the 0 button, and then it'll bring it back to 0, and then pour your I presume you used water, so pour your water in. So then the mass balance is only giving you the mass of the water because you've removed the mass of the beaker. And then the other way is to get your balance, put your beaker on when it's empty. Whatever it says here, you write it down. Then you add the liquid in. It'll give you a new reading here. You write that down. And then you subtract the two readings. And then you're left with just the water. Okay, so it didn't matter which one you did, they both work absolutely fine. Again, though, when you get your reading for water, let's say it's 110 grams, you need to divide it by 1,000 and tell me that it's 0.11 kilograms. Okay, you need to do that bit. Now, the last bit, okay, I don't know, I had asked Miss McDonald to throw these out into the lab. I don't know if they were thrown out into the lab, but this is what I was getting at. I don't know if you've seen these before. The reason I mentioned suitcases is because I have one at home here for my suitcase. So I was saying when things are awkward, like a bag or something like that, and you put it up onto a scales, what happens is, you know, if you place something large onto a scales, you can't actually see the bit where you read it. So these are really handy for that. So you pick them up, and this bit here goes in and out, and then you can read off what the mass is on the scale up here, okay? These are called a Newton's spring balance. It shouldn't just be a spring balance, it should be a Newton spring balance. And it will measure the mass. I don't know why it says apple or banana, but it will measure the mass of something that doesn't easily measure on a mass balance or at home on a scale. Okay, so it's another way of measuring mass. I want that added into your notes, please, because of all the experiments I looked at about 7 or 8, nobody had mentioned that. Okay, so that's just a little wrap up on the experiment, but you did it really, really well. Now, volume is next. So the volume of an object is the amount of space it takes up. Another word for volume is capacity. Okay, and I think that gives you the idea of space. Okay, the amount of space it takes up, or the capacity. The SI unit for volume will need to go in, meter cubed. So with volume, remember with area you were measuring length and width. So here was your length, here was your width, that was your 2 dimensions. This was in meters, this was in meters, so that's where the meter squared came from. Whereas now, when we're doing what's wrong with that? Sorry. Now when we're doing volume, okay, we're talking about 3 dimensions.
Hello.